Hello everyone, I'm Kitana and I'm an engineer at Supermicro. Today I'll be walking you through how to set up Stable Diffusion XL Turbo on Supermicro's Gaudi 2 AI server. For an overview, we'll be using Gaudi 2 AI server, Ubuntu 2204, Intel Gaudi software suite, Stable Diffusion XL Turbo model, Optimum Habana GitHub, and then following a demonstration. Here's a sneak peek on the server, which we'll explore a little bit later. Before we get started, please note that we've already downloaded the model prior. Here's some list of the prerequisites and links for future reference. Here we have the landing page for Supermicro's Gaudi 2. This is a game-changing AI accelerator that is reshaping the landscape of machine learning and deep learning in AI. It delivers exceptional performance, energy efficiency, scalability, versatility, and cost effectiveness. Please refer to this link to get all the rest of the specs of the server. We'll be using only one of the HPUs on bare metal. The Gaudi 2 server is based on the X12 generation powered by two Intel Xeon 3 CPUs, 8 Gaudi 2 AI accelerators. Each OAM is up to 600 watts TDP. For more details on the specs, or reach out to our team in Supermicro Technology Enablement. Let's go over the model card. For XDXL Turbo, it is a text-to-image diffusion model, which uses fewer steps than the original. Next, we have the Intel Gaudi documentation site. This is where you will begin to access files, download, and find supporting resources. The processor offers 2.4 terabits of networking bandwidth, 96 gigabytes of HBM2E memory, and supporting all popular data types required for deep learning. Our first step is to verify the firmware and driver versions using HLSMI, which is Habana's system management interface tool. This ensures that we are working with currently supported versions and operating systems within our support matrix. Navigate back to the Intel Gaudi docs for installation on bare metal to install Intel Gaudi software suite on a fresh OS. We'll need to use the command line to pull from the Habana Labs vault the Habana Labs installer for PyTorch. Please follow the documentation listed here for an in-depth review. Make sure to review the currently supported versions and operating systems within the support matrix. We'll start up by setting up our Habana Labs virtual environment, which we've previously installed. We're going to be calling this environment name with a postfix of SDXL demo. This is just setting up the virtual environment. Be sure to click yes so that we get all the packages and dependencies installed. Then activate the virtual environment using source, the name of the virtual environment, bin/activate. We want to make a directory called SDXL Turbo Demo, which will house all of the directories. It's currently empty. On your web browser, please navigate to Hugging Face Optimum Habana GitHub repository. We'll be using the latest branch release, which is a tag. Please note that the main branch is their development branch, so we want to be using the latest stable release. Let's copy this and read a bit below. So we'll need to clone the repository into our directory. We'll follow the first two steps. Update the eager mode because we're doing a demonstration on bare metal. And then we'll just check out that latest tag. Following that, we'll need to change into the examples directory, change into Stable Diffusion, run an installation script for the requirements, and also for deep speed for that dependency. Let's check out the Stable Diffusion example that they have here. Our team has created a web GUI that utilizes some of this code just for a more user-friendly experience. Note that we have already downloaded the SDXL model prior to this. Okay. And that is the model there. So our first step is installing the eager mode. This is sped up a bit. Now we need to clone the repository, switch to the latest stable branch. After this is done downloading, we will switch into the examples stable diffusion folder and install the dependency for deep speed. In our next step, as that has been downloading, we'll skip ahead and install the requirements text folder. Next, we'll install Gradio. It is an open source Python package that allows you to quickly create easy-to-use, customizable UI components for your ML AI model. Our team used this open source front-end framework to create an interactive and friendly UI for our application here. As this downloads, our next step will be to verify that we have our script in here. I'll be installing the script and the image off screen. We have the script loaded and the image is going to be the SMC icon. Let's execute the script by typing Python, the script name. It's important to note that for an HPU, graph compilation may take some time for the first few iterations. However, after the HPU has been sufficiently warmed up and the graph is able to compile, it'll be saved in a local cache, so that next time when you run it, it just loads the graph as necessary. You can see that it's noted previously as I'd highlight it in the warm-up steps. Okay, let's launch our application, enter in the credentials. Here is our example. I have a little bit of a description there. You can enter into text prompt. We will be using some of the examples that have an example step size and seed. Our first example is a cute cat with a step size of 1 and a seed of 99. The seed represents the random seed to initialize the LLM sampling to ensure varied output. The step size represents the resolution output of the input. Note that SDXL Turbo uses the method called adversarial diffusion distillation, which allows for sampling large-scale foundational images 1 in 4 steps for higher image quality. This essentially means that we're able to get higher quality images with fewer steps. Note that the reason why the graph is taking a little bit longer to load for the first iteration is, like I said earlier, HPUs take a little bit of time for the initial warm-up. And here's our cute cat. After we go through a couple more of these images down here, they will be able to load much, much quicker. And I'm only using the examples I have here, but because we have faster load times, our team was able to also use live reaction for the text that we have. Thanks for joining me today on setting up SDXL Turbo on Supermicro's Intel Gaudi. For more additional resources, please follow the links or feel free to reach out to Supermicro Technology Enablement. Don't forget to like and subscribe for more content from our team.